This video will show you how to calculate molecular weight, molar weight, and molarity. So let's start with molecular weight first. The name molecular weight is exactly what it means. It's the weight of a molecule. And remember, you get molecules by combining different elements through chemical bonds. So molecules like these listed here a lot of times will have different elements joined together. So the molecular weight of a substance or a molecule, to figure it out, all you have to do is add up the atomic mass, because this is the weight of each atom. And the unit is always Dalton, because the unit for atomic mass is Dalton. So I'm going to give you an example. Let's try to calculate CO2, okay? So all you have to do is you will go to your periodic table, and let's go there. So we want to look at the molecular weight of CO2. So all you have to do is look at carbon. Let's do this, CO2. So carbon, the molecular weight is 12. Remember, the two numbers in the periodic table, the bigger number is always the atomic mass, okay? The smaller number is always the atomic number. So carbon, we have 12 here. And we look at oxygen here. The atomic mass is 16, it's 15.99. So we're going to round it up to 16. 16. But in this molecule, CO2, we have 2 oxygens. So we have to multiply this 16 by 2. So once you do that, we have 32 here. So now the very last step is to add these two numbers together. So this way you end up with 44. Now remember, atomic mass unit is Dalton. So that's why this molecular weight, since we use atomic mass to figure it out, at the end the unit will be 44 Dalton, or AMU, whatever you want to use. Okay, so pretty straightforward. That's how you figure out molecular weight. Now I would like you guys to try to figure out the molecular weight for H2O and CH4. Remember the number next to the element showing you how many of the element is in the molecule, okay? So I want you to pause the video right now and try to figure it out what the molecular weight for these two molecules are. And then once you figure it out, you can resume and I'll tell you what they are. Okay, now let's check your answer. For H2O, if you look at your periodic table, you'll know that hydrogen atomic mass is 1 Dalton. And since we have 2 of those, so we have to multiply that by 2. And we just did oxygen, and oxygen is 16, right? So then when you add these two numbers together, then the molecular weight for water should be 18. Remember, unit is always Dalton because it's same as the atomic mass. Now for CH4, carbon is 12 Dalton. Hydrogen is 1. We have 4 of those, so multiply by 4. So when you add these together, it should be 16 Dalton. Okay, the key thing to remember is to use your periodic table and to use the atomic mass, and the unit is always going to be Dalton. Next, we're gonna do molar weight. So the term molar weight is, instead of looking at the weight of a molecule, we're looking at how much does 1 mole of a certain molecule weigh. So the unit mole is 6 times 10 to the 23rd. So that's that many. So when we talk about a mole of water, we are talking about 6 times 10 to the 23rd molecules of water. Okay, so to calculate the molar weight of water, first thing you have to do is to figure out the molecular weight of water first. And once you figure out the molecular weight of water, all you have to do is change the unit from Dalton to grams. Okay, and remember, molar weight is always expressed in units in grams. So let's do an example of calcium chloride. To calculate the molar weight of calcium chloride, which means we're trying to figure out how much does 6 times 10 to the 23rd molecules of calcium chloride weight, we have to figure out the molecular weight of calcium chloride first. And you learned that from the last few minutes. You have to go to your periodic table, look at the atomic mass of calcium, which is 40 Dalton. Okay, so here's calcium. Chloride. And chloride, the molecular weight is 35. I'm just going to make it easy to calculate. And since we have 2 of those, remember the 2 means how many element there is of that kind. So I need to multiply that by 2. So then to figure out the molecular weight, I add these 2 together. So it's 70 plus 40. So for molecular weight, I have 110 Dalton. So to turn this molecular weight into molar weight, all you have to do is take this number and change the unit to grams. So 1 mole of calcium chloride will be 110 grams. Okay, remember this is telling you not 1 molecule. So here's the difference. This here, molecular weight, is telling you how much does 1 molecule of calcium chloride weight. And this 110 gram tell you 1 mole, which is 6 times 10 to the 23rd molecules of calcium chloride will weigh that much. Last one we want to talk about is molarity. And a lot of times you will see that in the lab, that's designated as big M here. So the unit molarity is talking about how many moles is in 1 liter of solution. So this is very useful when you try to make solution in the lab. So it's moles per liter, that's the unit, okay? So when you see this here, 1 molarity is talking about this solution will have 1 mole of whatever substance or chemical you're looking at per liter of solution. So the denominator is always a liter. So it's 1000 ml. Okay, and you remember from the last one we did, 1 mole is 6 times 10 to the 23rd molecules of whatever substance you're looking at. Okay, so same thing, if you're looking at 2 molarity, you just change the numerator to 2 moles, and that becomes 2 molarity. And a lot of time, molarity is coupled with scientific notation. So if you see here, we have millimolar, big M molarity, milli means that it's 1 times 10 to the minus 3rd moles per liter. And micro is 1 times 10 to the minus 6. So these prefixes will tell you how many moles per liter. Now let's do an example of how to calculate molarity, okay? So let's say we want to calculate the molarity. Well, in this case, they want to look at how do you make 3 molarity of sodium chloride. So this you get to use all the things you just learned. Number one, you have to figure out the molecular weight first. Okay? And then, after you figure out the molecular weight, you turn the molecular weight, change its unit to become molar weight. And then lastly, you just look at how many molarity you're dealing with. You just multiply that number. So let's do this together, okay? If you look at your periodic table, you'll find that sodium has atomic mass of 23. Chloride has atomic mass of 35. So the molecular weight for sodium chloride should be 58. Remember, the unit is always going to be Dalton for molecular weight because atomic mass unit is Dalton. 58 Dalton. So now, what is the molar weight? How much is 1 mole of that weight? So the molar weight then will be 58 gram. Okay. So now, since we know 1 mole of sodium chloride is 58 gram, we want to make 3 molar solution. So all we have to do is multiply this molar weight by 3. So we have 3 moles, right? That's what 3 molarity means. So 3 moles, remember the unit is per liter. Per liter. So all we have to do is do the conversion. Do 3 times 58 gram. Remember, over 1 liter. So when you do 3 times 58, you'll get 174. So to make 3 molar solution, you will need to add 174 gram of sodium chloride in 1 liter of solution. And that's how you make 3 molar sodium chloride. Okay, so I hope that's helpful.